So we're looking at the experiment that you guys are going to be doing today or watching this week is different types of chemical reactions. Okay. And remember that when you have a chemical reaction, you always need to make sure that it's balanced. We covered this in lecture. You guys should be expert in terms of balancing it. So I'm not really going to cover this in detail. Okay. Um, because you guys should already know how to balance chemical equations. You cover that in your midterm. Just make sure that the cardinal rule is the law of conservation of mass. That is, the total atoms that you have in the beginning has to be equal to the total atoms that you have in the end. Also recall that once you've established the formula, you cannot change the formula, because once you change the formula, then you change the chemical reaction itself. The only thing you can do is change how many of that chemical you have in the reaction. And that's done by changing the coefficient. That's the number in front of the chemical formula. So what are the evidence that a chemical reaction is taking place? And this is what you need to write down when you see the observation. How do you know a chemical reaction is taking place? Well, you need to cite these evidence. The first one is that there is some sort of gas formation, or maybe you can see some sort of fire. And when there's fire, there's usually smoke, and that smoke is a gas formation, like the combustion reaction of ethanol or some sort of hydrocarbon. There's also precipitate. If you take two liquids and you mix it and you start to see this cloudy color, even if it's not yellow like in this picture, but it's sort of like white or milky, those are particles suspended in the water. And if you centrifuge it down, you'll see that you can collect it. So the precipitate is indicated by S in the atomic formula when you balance a chemical reaction. Precipitate by S. When something dissolves, you indicate that that chemical is dissolved in water by the symbol AQ. Another symbol or another sign that a chemical reaction is taking place is that if a temperature change occurs. And usually this happens because bonds are being broken and new bonds are being formed. Sometimes it's very difficult to monitor the temperature change, but if you have a thermometer, perhaps you can see how the temperature changes for a solution. So that's what's going on in terms of this um, particular case. So, hey, Jenny.
Oh,
Um,
I thought the meeting started at 3:30 as in schedule.
yeah, I saw. I'm sorry. Usually after class, depending on how early we're done, we usually start class at 3:05.
Okay.
So
Got it.
that's generally it. And sometimes I delay it because I'm just um, near the end in terms of my lecture, and sometimes I have difficulty logging on to Zoom or hooking up my difficulty. If that's the case, I usually send out an announcement. But thanks for attending. I can
Okay.
see that folks are coming in now.
Yeah,
Uh,
sorry, because the schedule say online on Canvas it say 3:30. I guess
oh,
that's why
really?
I'm late.
Okay.
Yeah.
I'll make sure and change that. It's always easier, I guess, to make it later if you set an early time on Canvas. So I'll make sure I change that.
Okay. Thank you.
Okay. But I'm just talking. I'm just giving a PowerPoint discussion at this point, and I'm just showing the students here what what this experiment's about, and I'm going through the different modules, what that these guys are covering. So this is the PowerPoint slide for those of you who just arrived, and I just talked about what you guys are going to be writing down in your observations. That is, that a reaction has taken place. So I just started. Um, when you see a gas, make sure you indicate that in your observation that a gas has formed. If you see something burning, make sure you write that down. If you see a precipitate, make sure you indicate that in your observation. Temperature change is very difficult unless there's a thermometer that's involved in the reaction, or whether the narrative tells you, the narrator of the movie tells you that it it becomes hot or becomes cold. Okay, if someone is narrating the chemical reactions in the movie, please make note of what they are saying, because that'll be part of your observation, because you guys are just watching the video. So temperature change is the third. And then the last thing that you guys can see here is that the color change. And the color change occurs because you're mixing two chemicals, and the new chemical has a different property, and that property is a color change. So if any of these things happen while you are observing the chemical reaction, then please make a note of that in your observation. Okay. So these are the different types of reaction that you guys are going to be studying. You guys are going to be studying the combination reaction. This is where two chemicals become one. And you guys have a pre-lab question where you're supposed to recognize what the reaction types are. Is it coming together, or is it breaking apart? Is it a single displacement? Is it a double displacement? And again, for those of you in my class, we covered this already back in chapter 7. So look at your notes, but here I'm going to reiterate it as well. Combination reactions are reactions in which two or more chemicals form one. So they're combining. The other type is the decomposition. That is where one becomes many. It could be two, it could be three, but it basically breaks apart. Here's an example of carbonic acid converting to water and carbon dioxide. That's a decomposition reaction. Single displacement. Single displacement is where one element, and it doesn't have to be one atom. It could be oxygen, H2. It could be sulfur, which is S8, but it's one element. And there could be multiples of this element, but one element substitute for another one in a ionic compound, or a compound in which there's two or more different species. So in this one, this first one right here, zinc replaces copper. So it displaces one element, copper. That's why it's called a single displacement. Okay, single displacement. Here we have calcium replacing one of the hydrogens in water. Water can be written this way. Okay, let me write water. Water can be written this way. Let me get my pen. And so what calcium is doing is replacing one of the hydrogens in water. So this hydrogen gets bumped off, and calcium comes in here and replaces that. But you guys remember that calcium is +2, hydroxide's -1. So it actually needs to displace two hydrogens for every one calcium. So you get CaOH2, and then the two hydrogens come together to form the hydrogen molecule. That's a single displacement. It doesn't look like a single displacement because you don't think of water as an ionic compound. But remember, single displacement is simply replacing one type of element in a compound that has two or more different atoms in it. This is the double displacement right here. These guys are simply switching partners. The barium is replacing hydrogen. The hydrogen is replacing barium. So you've got HNO3 and BAS. Make sure you know how to write chemical formulas, because if you write in here HNO3 parentheses 2, and you might say, oh, it's parentheses 2 because you have two nitrates here. That's wrong, because hydrogens +1, nitrates -1. So the correct formula is HNO3. What you need to do is you need to balance this equation so that the atoms on the left and the atoms on the right are equal. Okay, but you gotta first make sure you get the correct formula right. You gotta have the right chemical formula. Then, if you're confident with the right chemical formula, don't change the formula. Simply change the coefficient in front of that formula. So these are double displacement. A form of double displacement is actually acid-base. Here, the hydrogen is replaced by the cation of the base. So you form a salt. The metal and the anion, or the cation anion, that's a salt right there. It's ionic. And then H and OH forms water. So this is a double displacement, but more specifically, it's an acid-base neutralization reaction because one chemical is an acid, another chemical is the base. And then the last reaction is a combustion reaction. A combustion reaction is a reaction in which you have some fuel, you burn it in oxygen, you always get carbon dioxide and water and energy. But oxygen is also an ingredient in these combination reaction. So some of the questions in your lab will ask you, what type of reaction is this? And you just have to recognize the pattern. Is it a decomposition? Is it a double displacement? Is it a single displacement? Okay. And I'll show you where these are in the pre-lab as well. So this is just a summary of all the reactions I just talked about. So I'm not really going to go into the details of this. But again, these are just examples. If you want, you can practice balancing these equations. You guys will also get a lot of practice in the lab today. Okay, this is a reaction actually right here. These two reaction we actually do in our lab. One is the silver mirror experiment. It's a pretty cool experiment. What happens is you take some silver nitrate, potassium iodide, and then through the double displacement, you get the silver iodide coating the inside wall of the test tube. So it looks like your test tube converts into silver. So it's called the silver mirror experiment because the walls of the test tube looks like a mirror. But apologize that you guys don't have a hands-on experience in doing that. That's probably the coolest experiment in this particular lab. This is the iron chloride and ammonium hydroxide. Again, you guys are going to be doing this or at least watching these. So double displacement. I'm going to talk a little bit about this and show you a little animation that I did so that it's clear what you need to do to write out these equations, because a double displacement is probably one of the more difficult reactions to do because they want more detail for double displacement reaction than normal. So I'm going to take a little bit more time in this PowerPoint to show you how to do this. And again, recognize it's a double displacement because they're simply switching partner. If we were in class, I would say we were in divorce court, whereas these couples are not satisfied with each other. So they're basically switching partners. Okay, so that's double displacement reaction. Here's another double displacement in this particular case. One of the product is water. One of the product is water, but it's still a double displacement. The hydrogen is being replaced, and then it combines with an OH group, and what you get is H2O for one chemical, and then the cation and anion for the other partner, other species. Okay, so you can get a gas formation in a double displacement. Here's your gas formation. You can get water formed in a double displacement. Those are your product, and you can get a precipitate in a double displacement, and you know it's a precipitate because it says solid. When it says aqueous, it means that in water it stays as its separate ion. Okay, and I hope that will be clear in the movie that I'm going to be showing. So here's another form of double displacement, acid-base chemistry. Okay, here we have nitric acid and sodium hydroxide. The hydrogen and nitric acid and the OH and sodium hydroxide forms water, and you get sodium nitrate as the finished product. The other example that you guys are going to be doing in the lab is sulfuric acid and sodium hydroxide. The hydrogen and sulfuric acid reacts with the OH and sodium hydroxide, and then the other product you will get is sodium sulfate. I put a question mark there, but you guys should know that. Okay, and these are the results that you guys will see in this lab. So for double displacement reaction, make sure you understand how to read something called the solubility table. Let me just give you a review on the solubility table. Solubility table tells you which chemicals, when placed in water, will dissolve, which chemical will, when placed in water, will give you a precipitate, a solid. Any chemical that has nitrate, perchlorate, acetate in it If it has that as the anion, it's automatically going to dissolve. There are no exceptions. Anything with nitrate perchlorates acetate, all of it dissolves. Okay. Any chemical with the halogens like sodium chloride, sodium bromide, sodium iodide will dissolve, except here are the exceptions. If you got silver chloride, for example, that right there is a chemical that's not going to dissolve. It's going to precipitate out. And you saw that in the last experiment. Okay, silver chloride did not dissolve. Remember when you were analyzing anions? It gave you a precipitate. So if you've got silver chloride, bromide, or iodide, if you've got mercury chloride, bromide, or iodide, or if you got lead chloride, bromide, or iodide, they don't dissolve, they precipitate out. That's what this column means, the exception. Sulfates are generally soluble except calcium sulfate, barium sulfate, mercury sulfate, strontium sulfate, and lead sulfate. Otherwise, they're soluble. This is a very important rule right here. These two are important because both of these have no exceptions. Anything containing nitrates, chlorates, acetate will automatically dissolve. Anything with group 1 cations, that's sodium, lithium, potassium, rubidium, will always dissolve. There are no exceptions. Okay, even if you've got sodium sulfate, that'll dissolve. Even if you got sodium hydroxide, that'll dissolve. Even if you got sodium sulfide, that'll dissolve, because these two are takes priority over all the other rules. If you've got ammonium chloride, if you got ammonium chromate, it dissolves because there are no exceptions. Okay, so that's this column right here, solubility of substance. Insolubility, well, these are chemicals that generally do not dissolve in water. Okay, these are chemicals that generally do not. If you've got a carbonate, chromate, phosphate, sulfides, they generally tend to form a precipitate. Unless, of course, you've got sodium carbonate or you've got ammonium carbonate, and then this rule takes precedence. Otherwise, it's going to give you a precipitate. Okay, it's going to give you a precipitate. Hydroxides generally give you a precipitate, except the calcium, strontium, barium, alkali, and ammonia. That's this rule right here. Okay, so if you got barium hydroxide, that's going to dissolve. If you got strontium hydroxide, that's going to dissolve. If you got calcium hydroxide, that's going to dissolve. Magnesium hydroxide is not in here, so that's going to form a precipitate. So that's how you read the solubility table. And then you also have simple solubility tables that are out there. Okay, and that's what these are right here. And I think your book also gives solubility table. So let's take a look at this reaction. This is the main reaction that we're going to be studying: magnesium nitrate, potassium hydroxide. And again, it's a double displacement. So the magnesium will replace potassium, potassium will replace magnesium. So the product that you will get is potassium nitrate and magnesium hydroxide. Remember, magnesium's +2, hydroxide's -2. We know that nitrates are always soluble. That's why we put AQ here. There are no exceptions. And then potassium, that's a group 1. We also know that's always soluble. That's why we put an AQ here. Hydroxides generally are not soluble. Let's look over here. Hydroxide are not soluble unless you have calcium, strontium, barium, group 1, or ammonium. Well, magnesium is not in that list, so that's why it's a solid. That's why it's a solid. That forms a precipitate. Okay, let me clear this so I can show you the animation. I'm going to clear eraser. Oops, erase pen. Okay, so what happens is that you take the magnesium nitrate and you take the potassium hydroxide, those are your starting material, and then you put it in water. In these reactions, we're always dealing with water. And as it goes into water, magnesium and nitrate breaks apart into their ions. That's what AQ means, is that they separate into their ions. So I want to write that as how they exist in water, as their ions. Magnesium's +2, nitrate's -2. Of course, we need a 2 in front of that for the 2 nitrates here, but that's beside the point. Potassium hydroxide, likewise, it's soluble in water. So that's what's going to happen. They stay separated. Now they're going to switch partners. They're going to seek out new partners. The potassium and the nitrates are the new potential partners. But when they come together, it's still soluble in water. But let me go ahead and continue on with this. So that's the reaction that occurs. The potassium and the nitrates are the new partners, and then the magnesium and the hydroxide are the new partners. That's why it's called double displacement, because they're switching partner. If we want to write the formula, we would write potassium nitrate, but this is soluble in water, so we have to keep the AQ symbol there. Then the other combination is magnesium and hydroxide, but we know it's not soluble in water, so we need to put an S there. And so in solution, this is what happens. These guys, when you put it in water, they exist in ions, but it's only the magnesium and hydroxide that gives you a precipitate. So the top equation up here is called the molecular equation. The reason why it's called the molecular equation is because it shows all the chemicals in its neutral state. It's got its cation and anion. Okay, that's called the molecular equation. The bottom part here is called the complete ionic equation because it shows everything as it exists physically. That is, the magnesium nitrate, the potassium hydroxide exists as ions when you dissolve it. And then when they produce a precipitate, they still exist as ions, and only magnesium and hydroxide is responsible for the precipitate. That's why it's called the complete ionic equation. Okay, that's it right here. Now, if you take the complete ionic equation and recognize that this in the reactant and this in the product are identical, then you know that they weren't involved in the chemistry. They weren't involved in the production of the precipitate. So these are called spectator ions. Spectator ions. We're going to remove them because they're just in the bleacher watching the action. These are the other spectator ions. They have to be the same in the reactant and the product, as in their formula, as in their phase. So we remove them. And what's left is the chemicals responsible for the precipitate. That is the magnesium, the hydroxide, to give us magnesium hydroxide, which guess what? Is called the net ionic equation. The net ionic equation is only those chemicals. It's minus the spectators that is responsible for the chemistry of that new product that's being formed. So I hope this particular animation shows you how to write the 3 types of equation that you need to describe a double displacement equation. The complete molecular equation, that's this right here, the very top, which shows the neutral form. The net ionic equation, which shows you how these species exist in water, and it's only magnesium hydroxide that's a precipitate, and the net ionic equation, which minus the spectator ions gives you the chemicals that are responsible for the product formation. Okay, so whenever you have a double displacement reaction, if they're asking you for the complete ionic equation or the net ionic equation or the molecular equation, you know what to do. This is the hardest part in terms of chemical reaction because they really want more information from you. And later on, when you take more advanced chemistry, it's going to be important to know what is your net ionic equation, because that's really where the nitty-gritty of the synthesis is involved. So the last reaction that I haven't talked about yet is combustion reaction. And you know it's a combustion reaction because you see heat, you see energy, you see smoke, and the smoke is from carbon dioxide and water as our product. And then oxygen is required as an oxidizer to get this reaction going. Okay, so you guys know how to do that. So that basically is the PowerPoint I would usually show in the beginning of class, just to get you guys geared up for the reactions that you guys are going to be doing. So that's the first part. Let's look at the second part. That's the first link that you have. Remember, we are on the 11th week right here. And I just showed you this page right here. The pre-lab quiz. It's the quiz that I would usually give you at the beginning of class. It's worth 5 points. And then let me show you your pre-lab. Make sure that you complete the pre-lab quiz before Sunday. The pre-lab questions are those in your lab manual. Let's take a look at that. This is 10 points. I'll give you a preview. This is what it looks like. The first question in your pre-lab, in your experiment is, you've got CUI. What is the IUPAC name? Just pick the correct one. Next one is, what are the primary safety and environmental concerns involving copper solution? Make sure you pick the correct one, okay? Write the systematic IUPAC. Oops, is this the right experiment? No, it's not the right experiment. I think I picked the wrong one. Sorry. We are not here. We are, let me go back to my module page. Let's go over here to the 11th week. We are in experiment 7, not 6. I thought those questions looked familiar. It's very difficult to grasp that. So here's what if you look at your experiment, it gives you a chemical reaction. You need to balance it. So the first reaction is KClO3 going to KClO2. Balance it. If you have an equation and it's 1, that is, you're not putting a coefficient, you got to make sure and you put 1 there. Otherwise, it's going to mark you wrong. Not putting a number in front of that species means it's 0. So make sure you put a 1 if it's just one chemical. Don't leave it blank. A lot of you did that in my midterm. Okay. If it's 1, put 1. If it's 2, put 2. All I want are integers. Don't put fractions. They don't exist. And then the reaction type. And you want to use these letters, A, B, C, D, or A, B, C, or D. Don't type it out. It's going to mark you wrong. Okay, so please follow the directions. This is your first reaction. This is your second reaction, so on and so forth. This thing's automatically graded by Canvas. That way I don't have to go in and grade it. So that's why it's important that you follow directions. Put a coefficient when you're balancing the chemical reaction. Do the work first in your lab manual, and then type A, B, C, or D, not parentheses A, just A, B, C, or D for the different types. Then this right here, you guys are gonna go to the internet, look up a video on sodium reacting with water and potassium reacting with water. Copy and paste the URL here, and then write a sentence or two of what you observe, okay? That one I have to grade by hand. And then these are true, false. A soluble compound dissolves in water. Type in T or F. Don't type it out, true, T-R-U-E. It's gonna mark you wrong, okay? These things are based on an algorithm. It's gonna recognize either T or F, not T-R-U-E, or yes or no. Don't do that. Please follow the directions. Letters only, T or F. Then you're done. Okay, so that's the pre-lab. Let's go back to the module and then I'll show you the videos. Okay, so again, I need to collapse this because we're not in week 8. We are right here on week 11. Let's take a look at the video. And the video is pretty extensive. What I've done is I've tried to organize it so that it shows you the different parts. Here, what you have are the parts, A, B, C, D, and this is the YouTube, and it also shows you the title, okay? So let's take a look at the first experiment. Just click here. There you go. And okay, this is a full page. So
this is an example of a synthesis reaction. We're going to take a strip of magnesium and burn it in our Bunsen burner. We're going to use crucible tongs and hold the magnesium in the flame without directly looking. You never want to look directly.
Yeah,
at
you don't want to
the
look at it.
magnesium. It's going to be
Anyway,
very
you guys can
good.
watch it later. I'm going to move on. There's these different videos. Okay, I need to go in and code this so that this page actually stretches out, because right now it's not working. You can certainly click on this link right here and it'll open up to a new page. But I thought also you can do a preview. But anyway, that's besides the point. You can still see this. This is part A. That's magnesium burning. This is part B. There's two parts: the decomposition of cobalt chloride and the decomposition of baking soda. And this is that video right here. Okay. Then part C, hydrogen pop test, copper in silver wire, zinc reacting with hydrochloride. Part D, making silver iodide. This is that cool experiment I showed you about. I talked about earlier. Formation of the silver phosphate right here. Chloride and ammonium hydroxide. Part E, the last one. There's actually two parts in this one video. It's the titration reaction of nitric acid, HNO3 plus sodium hydroxide, and sulfuric acid with sodium hydroxide. And notice the comments here. It took 19 drops for the first part, and for part 2, it took 42 drops. The other comment here is in part B. It took 9 seconds for the first splint. It took 1 second for the second splint. So that's summarized in the bottom right here. These are the extra notes that you need, and you need this extra note when you answer the data sheet question. If you want to see the data sheet, just do a preview right here, and it gives you that data sheet. Okay. So that's where you find all the videos for this particular experiment. It's going to be found under video, data, worksheet, and data. So, and it's important that you watch the video because you're going to be graded on the detailed observations that you take. Now, when you complete the data, let's walk through this so that you guys can see what's required in this experiment. Okay. When you complete the data, and then you guys are going to submit the data here. So you go here to, if you want to download the data and upload the data, and it's got to be the worksheet as found in the lab manual. So the preview question, if you want to preview this, it's nothing more than a 1 question quiz. Says find your file and upload it. If you've got multiple pages, here are directions in terms of how to put all your pages into one folder and then to zip it and then upload that zip file. But let's take a look at the data because that's important. And I want to walk you guys through this. For the first video, you want to write down observations. Don't give me 1 sentence. Don't give me 1 word. Write a few sentences as to what happened. Okay, that's basically your observation. For if you need extra pages, then please say continue on an extra sheet. The decomposition reaction, you're going to make that observation. How long did the splint burn? Hey, remember, that's why I gave you that extra data. It told you how many seconds, one of the splint, how long the splint burned, and then the second one, how long the splint burned. You're going to write that down. Yeah, I know you guys didn't do it, but that's why we put it into this extra information. Single displacement reaction, you guys are writing down the observation. Double displacement reaction, you guys are writing down the observation. Writing down observation in science is very important. You don't want to just be haphazard. You don't want to be writing just 1 sentence. Oh, I see a flame, and then move on to the next one. It's got to be descriptive. Okay. Here's the neutralization reaction. Write your observation. How many drops of sodium hydroxide was required? We gave you that data. Your second reaction in part E, how many drops was required? For part A, B, C, and D. Now, these were your written observations for each of the video. Now you're going to be writing the reactions. For part A, magnesium metal plus molecular oxygen gives you magnesium hydroxide. make sure that you include the phase, make sure it's balanced, make sure you have the right chemical formula. So cobalt chloride hexahydrate goes to cobalt chloride plus water. Again, make sure you have the right formula. So these are where you write the balanced chemical equations, include the phase, make sure it has the correct coefficient. Here is where you write double displacement. See how you have silver nitrate, potassium iodide gives you silver iodide, and here they actually tell you which one's a precipitate. So you guys are going to write the complete ionic equation, and you're going to write the net ionic equation. And you saw that in the animation that I illustrated. So that's one. This is the second one, the complete ionic equation and the net ionic equation. Here, you're going to write the complete ionic equation and the net ionic equation. And if you can do that, for the rest of these, all of these are either single displacement or double displacement. Okay, so the first part was your observation. The second part is writing the equations, and then you're done. That's all you need to do for the data and observation. Let's go back and let's go to the last part. The last part is your post-lab update. So turn in your data sheet separately from your post-lab. That's why I allow you guys to download each section here, because this only shows the post-lab part. It doesn't show the data or it doesn't show the pre-lab. So the post-lab have these questions. Write them out and then upload them, and then you're done with this experiment. So this experiment requires you to make careful observations. That's where you're going to get a majority of points, and then writing balance equations. And once you do that and you upload your data sheet and you answer your post-lab questions, then you're done with this experiment. That pretty much is it. Okay, that pretty much is it. I don't think we have anything else here. Under week 11th, yeah, your data sheet and your post-lab. Your pre-lab, you take as a quiz. You don't upload that. You just answer the questions here. And then, of course, you have a pre-lab quiz. So the videos are fine on Canvas. Okay, well, good. I'm glad that worked out. The formula of zinc phosphate is wrong. You got to remember, okay, if the formula in zinc phosphate is wrong, remember that phosphate is a -3 and zinc is a +2. Let me just see. You know,
Pre-lab questions.
pre-lab questions.
Yeah.
Let me take a look at that.
Yeah.
That one right there. Let me take a look at that. So zinc phosphate.
No, question 1 and the number 2. Question 1 is
Yeah, this one is wrong. I need to fix that. It's ZN2PO43. I wonder where I got that. I must have gotten it from some source. Okay, but let me fix that before you guys balance that. Otherwise, you guys are going to get that wrong. Thanks for correcting me, Jenny. Yeah, that's the wrong formula. The correct formula for zinc phosphate is ZN2PO4 (3). I mean ZN3 (PO42). I apologize for that. Okay. Are there any other questions? In fact, let me just change that right now. Okay, change that right now and see, make sure that that is corrected. If there's no other questions.
I have a couple questions.
Sure.
One, you probably don't know, but maybe if you can find out, if we can get access to the lab. I left my goggles in the locker, so
yeah,
sure
you should have told me that before yesterday. I was actually able to sneak in. I got special permission to go in and get, because I left my lab manual with all the key in my office, and I was able to spend an hour in the lab to get that, and so I would have been able to go in.
So the answer is yesterday.
Yeah, the answer was yesterday, exactly. But if you need a pair of goggles, yeah, I apologize. I have no access.
I mean, I have safety
But-
glasses. The goggles are just more comfortable.
Yeah, they are. If you guys are going to, and they don't even know if you guys are going to be able to get back at the end of the semester. Here's that question. I think I've corrected it. ZN3PO4 parentheses 2. Okay. Yeah, in terms of recovering all your equipment in the lockers, as soon as it's safe to do so, what I think the lab tech will do is take all the personal belongings in a zip and put a locker number down. And so when you guys have time, hopefully you can retrieve it. And then of course we'll put an announcement that that'll happen, but it won't happen until we're given the okay that we can go back. Okay, I apologize for that. Anything else? Do we download the worksheet? You can download the worksheet, or you can just rip it off from, actually write it in your lab manual and then take a picture of it in your lab manual, because the picture, if you don't have a scanner, is going to be what you're uploading, okay, for the data sheet and the post lab. So you don't even have to rip it off from your lab manual. You can just take a picture of those pages from your lab manual. And remember, when you put it in your computer, when you download it from your camera to your computer, it's going to be separate files. You need to put it in one folder. You need to give it a proper name so I can identify it's you. And then you need to compress it or zip it so it's one file, and then you upload that.